Hey guys, welcome back to your algebra class. This is the using the square root method to find your roots lesson, and you're going to need just a regular piece of paper to take notes on while you watch this video. So what you remember is to find the roots, what you're really looking for is where does your parabola cross the x-axis? So far we've learned how to find the roots with factoring, completing the square, and now we're going to learn a new method called the square root method. And this only works with the missing bx term. So normally you see ax squared plus bx plus c, that's your trinomial. That's the shape that turns into a parabola when graphed. So this method, because it's also usually kids' favorites, this can only be used if this bx term is missing. So this is important. The fact that, again, the square root method will only work when that middle term, that bx term, is not there. And we'll start off with a problem where you'll see that the middle term is not there. So we've got the equation x squared minus 4 equals 0. So your a value is 1, the number that's in front of x squared. Your b value is not there, and your c value is 4. So what you're going to do to figure this out is you're going to treat this like a regular equation that you solve for x. So in order to solve for x here, I want to isolate x. So to do that, I'm going to add 4 to both sides of the equation to keep it balanced. And when I do that, I'm left with x squared equals 4. Now to get x completely alone, I have to use inverse operation, and instead of squaring, the opposite of that would be to square root. So I need to take the square root of both sides of the equation, and when I do that, my answer becomes not just 2, but if you remember, the square root of 4 is plus or minus 2. So I have two answers here. I can write it like x equals plus or minus 2, or if you'd prefer to just break it up into two answers, you could say x equals 2 or x equals negative 2. Either answer will suffice. Personally, I like this answer, the plus or minus 2, just because it's quick, it's to the point, and it works. Now you might want to pause the video now if you don't have this page written down, because I do have to go to a new blank page in a second. Okay, example 2. X squared minus 20 equals 0. So again, we need to isolate our x squared term. So we're going to add 20 to both sides of our equation. And we'll be left with x squared equals 20. And you might have picked up already that you should then take the square root of both sides to get that x squared down to just regular x. And now here, 20 is not a perfect square, so we're not going to just get some nice integer answer. But if we remember what we did the other day, where we simplified our radical, off to the side, what you're going to want to do is list all of the factors of 20 until you can come up with the combination that has the largest perfect square in the list. So if you look at all the factors, the largest perfect square listed is 4. And if you remember the square root of 4, that will turn to 2. But before I write the 2, I have to remember that all my answers are going to be plus or minus. So then I can write 2, and the square root of 5 can't simplify, so we just write it with the square root of 5. So my final answer here is x equals plus or minus 2 radical 5. And again, you might want to pause the video if you don't have everything written down, because I do have to go to a new page. So here we go. Okay, example number 3. X squared plus 49 equals 0. So you've probably already guessed it. The first step you want to do is isolate the x term. So you should subtract 49 from both sides of the equation. You're left with x squared equals negative 49. Now, when you take the square root of both sides to get x alone, whoops, I didn't mean to cut off that negative, you might automatically assume that your answer would be plus or minus 7 because 49 is a perfect square. However, that negative makes a difference. And if you typed into your graphing calculator the square root of negative 49, your school calculator would say non-real calculation. Okay? And the reason it's going to tell you that it's a non-real calculation is because if you take the square root of a negative number, then the answer doesn't exist. And in math, we call that an imaginary number. So what that means as far as finding the root of this equation is that therefore, remember those 3 dots just mean therefore, there are no roots. So if we had to do a sketch of what this would look like on a graph, then our sketch would look something like, here's my xy axis, and then maybe here is what my parabola would look like. Yeah, lovely picture. But the point is that it's going to be a U-shaped parabola because my x squared is positive, and it will never cross the x-axis, and therefore it won't have any roots. Okay, example 4. X squared minus 24 equals 0. Now, at any point in this video, if you want to try a problem before I give you the answer, feel free to pause it at any point so that you can try it and see if your answer matches mine. Okay, so you should add 24 to both sides. You're left with x squared equals 24. When you take the square root of both sides, you know that your answer is going to be plus or minus to begin. 24 is not a perfect square. So off to the side, you might want to list all of the factors. And of those factors, the largest perfect square is the square root of 4. Now we know the square root of 4 turns into 2. And then we just bring down the radical 6 because that cannot be simplified any further. So our final answer is x equals plus or minus 2 radical 6. Okay, only 2 more examples, so bear with me. We've got 3x squared minus 12 equals 0. So you should start by adding 12 to both sides. You're left with 3x squared equals 12. Now before we can take the square root, we should divide both sides by 3 to isolate the x squared. And now when we take the square root of both sides, you'll notice that 4, or you should recognize that 4 is a perfect square. So my answer will be a nice integer answer. X will equal plus or minus 2. And again, it's important to remember what you're actually finding so that we have some sort of meaning to this. So really what you just found was, here's my parabola, and this particular parabola would cross the x-axis at -2 and +2. Okay, last example that we're going to do, question 6. Instead of using the square root method, I want us to factor because I feel like it's been a while since we've had to factor to find the roots, and I want you to be well versed in more than one category. So in this scenario, we've got x squared minus 81 equals 0. Now rather than isolating x, we're going to factor, and if you remember how to factor a problem like this, we should recognize that this is the difference of two perfect squares. And with the difference of two perfect squares, it's helpful to understand that what you have to do is take the square root of both of those. Now, the square root of x squared is x, and that's what starts our parentheses, and the square root of 81, remember, is plus or minus 9. And that is why when we factor, it's the same concept that one parenthesis will be plus 9 and the other will be minus 9. Now, after you factor, the next step in solving is to set each factor equal to 0. So we've got x plus 9 equals 0 or x minus 9 equals 0. After you set each factor equal to 0, you simply solve each equation for x. So both of these will be one-step equations, where in one step we would subtract 9, in the other equation we would be adding 9. And so our answers will turn into x equals 9 or x equals positive 9. And again, you can write it as two separate answers, or you can write it as x equals plus or minus 9. Same thing. And that concludes our notes for today.